All right, so let's go ahead and jump into Module 1, understanding the DevOps culture. Where did all this come from? How did we get to where we are with today's state of how we develop and deploy software? The learning objectives for this module are to understand the evolution of the software development lifecycle and to come away with an understanding of what DevOps is. You'll learn to implement DevOps in an on-premise environment. You'll learn to implement DevOps in an AWS Cloud Native environment. You'll learn what that looks like in the Azure Cloud Native environment. And you'll understand the frameworks and the maturity model in DevOps. And lastly, we'll evaluate security silos in DevOps. So let's get started. First of all, understanding the evolution of the software development lifecycle. Organizations use different software development. These methodologies have continuously evolved and have both advantages and disadvantages as far as how well they work for individual organizations, customers, the velocity at which we can develop software, etc. There were three primary approaches to it. We had the waterfall methodology, which was the conventional systems development lifecycle maintenance approach. And it follows a top-down approach in which the development is performed in stages and the output of the previous stage is used as the input for the next stage. It wasn't suitable for long-term projects or projects that required regular modifications. Hence, the agile methodology was introduced to provide some agility in the SDLC process. This methodology basically follows the continuous iteration of development and testing through the software development lifecycle. The agile methodology introduced agility into the development process. On the other hand, the DevOps methodology enhances collaboration and productivity by continuous integration, continuous delivery, and continuous deployment. We'll see how all this comes together in a bit. The waterfall methodology, like I said earlier, everything that happened subsequent to one piece of this process took inputs from the previous piece of the process. The phases cascade into each other, and the process can be perceived as water flowing steadily downstream, similar to the waterfall. The waterfall model is used for small applications with predefined requirements that don't change frequently. It's great for little static projects that aren't of a complex nature, etc. It's a simple methodology that's easy to understand and implement. Each phase is well-defined and therefore easy to maintain. Quality is maintained and results are well documented at each phase. And we see you have the requirements: system design, implementation, system testing, system deployment, and system maintenance phases in the waterfall methodology. There were some drawbacks with the waterfall methodology. Primarily, it's difficult to implement changes in requirements once the application development reaches the testing phase. Returning to the previous stages makes it very, very difficult if something changes in requirements, needs, etc. The product delivery is delayed as no prototype is created intermediately, and the end product is delivered at the end of the cycle. And so it's kind of what you developed is what you get. There's a lot of risk, and it's uncertain as far as what's going to happen with the project because of the nature of it relying on each previous step into the subsequent ones. It's difficult to identify challenges and risks in advance because testing is performed at later stages once the code's developed and pushed out into this methodology. So basically, on the right, you see that additional requirements necessitate restarting of the development cycle, and I've seen this happen. A large web development effort at a company, they asked me to evaluate the security in it. I came in, and they were at the very final stages. It was a 5-month project that was 3 weeks from deployment, and the security was inadequate, and so we had to kind of hit a reset button on the whole thing. And there's no prototype that's typically created. If the client is unsatisfied with the product development must be restarted, resulting in delay. So again, it's kind of like what you code is what you get. Now in the Agile methodology. It's an iterative software approach to development of software. Each iteration or sprint follows the waterfall model in terms of requirements gathering, the design, the development, testing, and maintenance. But we do this in kind of like this looping fashion. You have iterations that you run through. And so it helps to kind of clean up problems. The entire cycle kicks off again. And as you work through an application's capabilities or its usability, it refines as it goes. The advantages, it provides a flexible model for the design, and it's suitable for applications that require a quick response to changes in the requirements. Enables collaboration and communication between the user and the developers. It creates prototypes based on the client's requirements. Typically, within that cycle, you'll have a delivery of a model of what it'll look like. And basically, the overall agile workflow is you have the product backlog, sprint planning, sprint backlog, and then you actually run into the sprint where the work is done. You have the deliverable product that goes in for review. And this is kind of like a lather, rinse, repeat approach to software development. Once this is completed, you start it again, looking at the product backlog as far as what has to be done, and then you plan the next sprint into that. There are some drawbacks with this methodology. Basically, complex applications don't fit into this model very well because of the time and effort is somewhat difficult to apply in an entirely new start over and work toward the end result of a sprint. It involves high risk in terms of sustainability, maintainability, and extensibility. If requirements change and you have to move quickly, you have to fire up an entire new sprint in that process. It relies on the client understanding of the requirements quite a bit. So you have to take their feedback. The product is tested only at the developer's system and not on the production server. So you're not really sure how it's going to behave once it's shoved up into the production environment. And we all know that production versus test environments typically don't align real well. The development and the operations team pretty much work in silos. Developers develop, the operations team gets the environments ready, etc. And so they're each working independently. So here you see the developer submits product to operations for deployment, and the operations team gets the environment ready and shoves it over. If it fails in the production servers, the operations teams are pretty much clueless and send the product back to the development team. They'll do a rollback and a reject of the changes. And it gets to be pretty painful at that point. You restart another sprint. Now in the DevOps methodology, it's a different kind of an approach to that agile principle. It helps in making the operation agile by integrating the development and operation processes. Instead of having to have code put over to the operations team as you did at first, now we actually have an integration that occurs. It aims at fast software development. Continuous integration and collaboration enable quick code development, fast testing, and a swift feedback mechanism, helping to reduce the wait time of code deployments. So you have major code deployments going on continuously with this DevOps approach. The old method, you can see clients and requirements. Agile addresses the gap between the clients and developers very, very well. But between development testing and the operations and infrastructure team, there's a break. And so when we look at down below, you have to actually submit the application to the operations team for that implementation. With DevOps, what we're looking at is the integration of operations and development, basically. You have the applications, operations, and infrastructure both input to that deployment. And in some cases, they're even co-joined if we have like infrastructure as a service, et cetera, that we run within these. And we'll get into those later on as well. And then you have this feedback that's provided actively while this development infrastructure improvements are being done, the pushes of code. And so down below on the right, the dev side, you have plan, code, build, and test. On the ops side, you have release, deploy, operate, and monitor. And these are integrated operations. They're very, very closely tied to each other. And get away from the standard IT as a silo and development as a silo type of an operation. The advantages of the DevOps methodology. First, there's constant communication between the teams engaged in software development. So all of these teams are working collaboratively to produce the product. There are fewer software failures caused by the differences in infrastructure configuration, particularly if we can take infrastructure as a code approach. And we apply templates for consistency within the environments as far as what services are available, how the APIs interact, etc. And that's between the test environments development and the production environments. There's fast provisioning of new infrastructure with an IAC approach, this infrastructure approach. We can take the DevOps engineers and push environments much more quickly with new projects. There's an increased test automation capability in here as well. Instead of having to stop what you're doing to code, you can actually have build run steps or processes that automatically kick off code testing, et cetera, for your project. And so if a bug is detected, it can be taken care of fairly quickly and efficiently because it's automatically provided back to the development teams. There's quick and reliable delivery of application updates. Some updates are done because of compliance changes, some because of security changes, some because of customer changes and what they need. And what you can do is rapidly provide these updates in a continuous cycle again through a prioritization of delivery effort. There's fewer post-release errors because of the continuous testing that's done in order to get something to the production environment. You're fairly certain of what's being delivered by the time it hits production. And then, of course, at the end, you have improved user trust. When you use a DevOps approach, either the end user can see the appreciable results in their interfacing with your product, or they can actually become a part of that continuous improvement, continuous development approach by having them inserted into the user acceptance testing pieces of this, or have the environments set up for them to be able to thoroughly look through any changes prior to it hitting the larger production systems or their specific environments that you've enabled through IAC. Waterfall versus Agile versus DevOps methodology. Basically, the areas of differentiation with the approach. With Waterfall, you have fully predictable systems and what you're trying to design and get to. It's all up in the requirements, doesn't change much. Systems can be specified in advance, and Waterfall assumes that the business needs remain constant throughout a project. There's limited effort on, or a focus, if you will, to software development. With Agile, you have rapid delivery of software through the integration of business development, quality assurance, and you use these repeated sprint cycles, if you will. It assumes that the priority of business needs may change, and it's limited to software development, not a lot on the operations side. Again, Agile doesn't tend to integrate your IT ops with your developers. DevOps implements automation by cross-functional teams to deploy changes continuously. It provides continuous feedback through loop, and it's limited to development and operations. With the goals of Waterfall, we see that gathering and clarifying all the requirements up front is the primary piece of it working well for you. With Agile, there's continuous improvement and maturity in the application development. With DevOps, there's increased frequency and enhanced quality of application releases, as well as infrastructure updates. As far as the iteration, Waterfall is very sequential. Agile has these sprint cycles. It's an iterative approach. And with DevOps, We're talking about applying smaller, discrete, if you will, incremental corrections of problems in the code as these issues get discovered. They can be kind of like swept and cleaned up in a continuous cycle. Team collaboration in waterfall is small because basically you're working in silos. Agile, it's improved due to the short development cycles and highly engaged business aspects, but the small teams of designers and developers and testers are still somewhat segmented out. With DevOps, it's high because all the stakeholders in multiple teams are involved from the start to the beginning of this, of the program implementation. The quality, waterfall is typically low because the issues are not identified until the testing phase, and you're at a what you see is what you get kind of a phase. With Agile, it's improved because issues are identified for each sprint. In DevOps, it's extremely high because of automated unit testing during the project development. And everything that gets called out as far as an issue early on can get swept up into these releases. Risk is high with waterfall. Obviously, it decreases with Agile because of the project development that occurs in iterations. But it's extremely decreased with DevOps because of the surety of what you're doing at the end of a particular push or a cycle or whatever. There's no business ownership on waterfall. You get handed requirements and you shove something back out. There's integrated business with Agile and DevOps. The delivery value and scheduling is, with waterfall, it's fairly slow. Agile gets to be a little bit more rapid as far as daily or weekly delivery of and scheduling of what's going on. With DevOps, it's a continuous cycle. You're actually working off of assignments and things of people and resources to be able to produce the results that you want. Level of communication and documentation is extremely comprehensive in waterfall. Everybody has to know exactly where things are, constant updates as far as what people are doing. It's a little bit more lower when we look at Agile, and definitely less of an issue when we talk about DevOps because of the tools that we use provide communication and insight as far as what's going on. Level of automation with waterfall is extremely low. It's just kind of like moving a brick down the street by flipping it end to end. It's a little bit varied when we come into Agile as far as what gets used to automate these processes, et cetera. Depends on the specific implementation and what you're trying to accomplish, but it's very, very high in DevOps. We're talking about relatively advanced tools that integrate to manage not just libraries of code, but also how they get deployed in what environments when, who's working on what, how the infrastructure is going to be changed to be able to accept the changes in code and the business needs, et cetera. A lot of automation's involved when we start talking about a DevOps implementation effort. Response to new business needs is relatively low with waterfall because requirements are baked up front. Agile is a little bit more responsive. You have it these sprints or these development cycles enables some changes, but again, it's kind of a do-over, if you will, event compared to something like a DevOps where it's highly responsive. Business requirements are defined precisely by those teams. Customer feedback is infrequent with waterfall, and at the end of a sprint, you get feedback on what was produced or developed. With DevOps, you have continuous capability to be able to see what's happening, what's being done, and if it's acceptable or needs changed, et cetera, or if it meets your business needs. So you can see on the right kind of what it looks like as far as waterfall. You get the design, you code, you test, you deploy. Agile is that repetition of code, test, deploy. And then with DevOps, it's this continuous cycle of coding and testing from a lot of different inputs and areas and things like that into a deployment event. Understanding what DevOps is. DevOps is basically an amalgam or a mix of cultural philosophies and tools and practices that enhances an organization's ability to generate robust quality software products and services at a faster pace compared to the conventional software development methodologies. With increased pace, an organization can provide better services to the customers and compete efficiently in the market. In other words, you have the ability to move quickly to the needs and shift to market demand. DevOps helps in effective collaboration and cooperation among previously siloed roles such as development, IT operations, quality engineering, and security to deliver secure and reliable soft products quickly. And so on the right, you can see that we have the big three pieces of DevOps. You have development of software engineering, operations on the IT side of how to support and provision that software. And on the side, you have quality assurance, and they all come into this DevOps kind of a focus. The main goals of DevOps methodology primarily is to save time and money. DevOps automation significantly reduces routine and repetitive tasks, helping save time and money. It improves software lifecycle predictability as far as incorporating security, let's say, from the initial development phase, and it reduces the possibility of last-minute issues because it's in this continuous forward-moving development type of a perspective. DevOps builds the corporate culture of innovation. Basically, when companies hear that you have a fully promoted and functioning DevOps environment, they look at your organization like you're more creative and you can experiment more with what would satisfy market conditions or customer needs. DevOps promotes higher quality and continuous releases. The implementation of it allows the organization to achieve robust quality, continuous software product release, and enhanced efficiencies throughout. A DevOps culture motivates the staff. Basically, it motivates developers to write clean code instead of short code that could create technical debt. And basically, what we mean by technical debt is that if we create a piece of code that introduces an issue in some fashion, like a security technical debt would be a hard-coded piece of credentials in the code, we have that problem moving forward. So in other words, we create something and move it forward into a production environment, knowing it's a problem, creates a technical debt. So on the left, you can see the main goals: lower error rates with code, achieve the business and customer requirements very quickly. It enhances the productivity of all the teams, manages interaction between different departments and groups to provide this cohesive orchestration, if you will. It optimizes development tasks and responsibilities to cut down redundancy and to do quick assignments of what needs to be done. It improves strategies and programs. Where are we trying to take this? You can have a better visual lens on that with DevOps. It improves strategies and programs, and you are allowed a faster feedback with this type of methodology. The main benefits of DevOps: number one is speed. Basically, you can get software developed and deployed faster and more efficiently, more accurately than you could before. You have lower deployment failures. The shorter development cycles allow the easy identification and rectification of errors. It reduces the number of deployment failures. These are picked up earlier in the cycle of development or throughout this entire development phase. You're looking for errors and problems as you move code in, as you move through the DevOps frameworks. It improves efficiency. With automation, the time required for developers to perform automated tasks is reduced. It helps to improve their efficiency overall. In other words, instead of being bogged down with the mundane, They're taking on what they're good at. They're doing what they're good at, which is creating that code. Innovation is allowed with product releases. You can focus more on finding innovative ways to solve issues instead of being tied up into the traditional type of development practices. As far as reliability, DevOps improves it. It allows developers to update the existing product without affecting the user experience. And as far as the cost, it can reduce the cost as far as maintenance and regular updates. One of the big things there is that you're taking away the errors and the issues that can be introduced into an environment with a DevOps approach. That technical debt again. The building blocks of DevOps, what all is included here. And of course, like anything else, we have people, processes, and products, or the technology. People, all teams that are involved in this collaborate and work together to achieve a common goal. And that even includes the customers. Processes can be automated and integrated that allow for efficiency as far as improving the productivity in transit to new and enhanced infrastructure or code. As far as the products, you really do have a wide range of products that you can select from. And so you need to take a close look at what all is available before choosing programming languages, tools, services to ensure that the technology is properly utilized within the organization. What is continuous integration and continuous development in DevOps? And we talked about this a little bit, the CI/CD piece of this. It basically makes this development very, very agile by integrating automation tools in the entire software-defined lifecycle. So if we look at this, continuous integration automatically tests and merges changes to help maintain the integrity of the code base. We look at the repeat and the build processes and the continuous integration into releases, and it gets cycled back through so that we have this integration that continuously occurs. We have delivery using advanced tools to test and validate the build thoroughly and pass it for the deployment. In a continuous delivery environment, the build is always releasable. In other words, it's maintained at a state where we can go with it. Every modification made with continuous deployment is automatically deployed to the product environment. So we see this repeat build process again, defect failure into the release, cycles back and forth, and then it gets shoved through with this continuous deployment of the code. And then at that point, all you have left to do is to really kind of monitor and operate the environment to make sure that everything's working as designed. And meanwhile, in the background, more improvements are coming with continuous deployments. Phases of the DevOps pipeline. Basically, in an on-prem environment, they're as follow. You plan, you code, you build, you test, you release, you deploy, you operate, and you monitor. So you still have these phases that you go through. They're just integrated and cycling all at the same time, pretty much. You'll have them going on collectively, if you will. So in the plan phase, customer requirements and feedback are collected for building a product roadmap that will help in future development. The developer writes the code and the software product on whatever platform they're using. Then you have a build. Utilizing a suitable programming language, a basic version of the product is built. You'll test it using automated testing tools in an environment slated for it. You release it. The build process is planned, scheduled, and controlled in different environments. And once the release is done of the code, you can deploy it. All the products and the files that are deployed are run on the server. Operations occur at that point. After the deployment, the software or product is delivered to the customer who uses software to meet their requirements, whoever that may be. It could be internal or external. And then you monitor the delivered product to identify errors, uptime, downtime, failures, etc., whatever's impacting it. So you still do have these discrete chunks of things that happen. They just kind of all tend to happen a lot at once. And they get controlled by the DevOps tools and things. DevOps practices. Number one is infrastructure as a code, being able to test and instantiate environments for code to run on is a critical part of the DevOps practices. This is where we tie in the traditional operations, IT operations, with the development efforts, get them into a single pane of view as far as what they're doing. You have continuous integration, automated testing. At every chance you get, you should be running automated testing on code and the environments themselves as well when we talk about IAC. Continuous deployment of updates and product improvements. Release management is done according to your deployment requirements for different environments, if you will, or different specific pieces of those environments. You have application performance monitoring that's done to make sure that it's hitting the targets and needs of not only your organization, but it's also done prior with some testing to see if things are going to work correctly. You have load testing and auto scaling that's done within the practice. Availability monitoring and SLA meeting, the meeting about availability monitoring, SLAs, etc. Changing configuration management is certainly a piece of this. No matter how complex it gets, we still track changes in configuration. Management's accomplished with templates and things. You have feature flags and automated environment deprovisioning that can be supported with it. Self-service environments are very, very common in a DevOps practice. Automated recovery and rollback and roll forward are provided. And there's hypothesis-driven development. You can do testing in production, you can inject faults, and you can do user monitoring and user telemetry to kind of investigate the what-ifs of products that are being developed and deployed. On-prem DevOps versus cloud-native ops. DevOps principles can be applied to both cloud as well as on-premise software deployment projects. The main difference between the two is in the delivery method. In the cloud, release and deployment are pretty much the same. With on-prem DevOps, the development team is responsible for delivering the release to the deployment team. The deployment team has to plan with the client before deploying the new release, especially if the deployment requires any kind of a downtime or break in service to those customers. And you can see it kind of like on the left there a little bit, how you have the deployment goes to the deployment team. They release it, you have the code pipeline, gets built, static code analysis occurs, and there's a security analysis. And then the development team deploys the code commit once this is done. With the cloud DevOps approach, the development team is responsible for deployment as well. If there's a separate deployment team, it works with the development team using the native tools provided by the cloud provider. And we'll get into some of those native tools and what they look like. The deployment does not require any planning really with the client because it's all cloud and it's rolled in. This gets back into the cycle of typically using other environments where customers may see your code prior to it, or you get the requirements rolled up and rolled in, and it just gets to be a triggered event. So you have the deployment team with the code pipeline and the build occurs, security analysis is done. The development team up top does the code commit, and it kind of dovetails them into this process a little bit differently. So the DevOps tools, they enable developers and operations teams to build, test, deploy, and monitor applications quickly and accurately. These tools provide transparency, automation, and collaboration across the organization. The selection of appropriate DevOps tools is vital for the successful implementation of DevOps. And that's really critical that you select the right tools that's going to fit not only your needs, but the environments, the customers, what they're requiring, etc. Categories of DevOps tools. There's continuous integration tools. These tools enable continuous feedback on code integrations, and it helps stakeholders and developers to identify and solve problems quickly and reduce the overall software release times, the cycles, which is what you're after with DevOps. There's continuous delivery tools. These tools are used as a part of the delivery pipeline and enables this continuous delivery into the environments. There's infrastructure and configuration management tools. These basically provide the automation of servers and applications configurations in your environments. and what they look like as far as templates, etc. There's container clustering and orchestration tools. They enable microservice-based deployment, which logically clusters these into the services that the systems are actually providing to the application, to the customer, etc. There's application and infrastructure logging and monitoring and visualization tools. Therefore, monitoring the infrastructure and application either throughout the cycle or in the production environment. There's the collaboration side of it. And basically what these do is they enable the development and operations team to collaborate for software delivery. We used to think of Microsoft Project as the old one. Well, things have changed now with Jira and things like that, and we'll get into that in a little bit. There's the source code management tools, and these enable tracking changes on source code repositories, so you have the change controls, who did what, as far as not only changes in the code, but the commits and things that occur through there, the builds. There's the developer productivity tools, and they help to maintain consistency in the development environment and help the team track it by providing schedules for team members. So you can actually see how efficient your team is with these tools. There's DevOps build tools. They help to automate the package creation when you're moving from one code from build to release, etc. There's artifact management tools for DevOps. These tools are used for storing and versioning the code to be deployed in production at a central location, kind of like a library for all of the artifacts that are used within an application or an application suite. There's bug issue tracking tools for DevOps. And basically these are used to track bug issues in the code and how they get remediated, who owns them, etc. You have test automation and performance testing tools that are used to automate the testing of the application, to test the performance of it so that you can stress test it or perform whatever tests you need for it to be able to implement well and work and function correctly within the production environment. DevOps services in the cloud. With source code management, Azure has what's called repos. Google Cloud Platform has source repositories, and AWS has code build. For package management of the artifacts that we were talking about, Azure, it's called artifacts. Google has the container registry, and AWS uses the Elastic Container energy. For the continuous improvement, continuous deploy, develop pipeline, Azure just calls it pipelines. Google calls it the cloud build, and AWS calls it code pipeline. Unit and integration testing is done with test plans in Azure, Spinnaker in Google, and code pipeline in AWS again. For project management, Azure uses boards. Google has available third-party options, such as Jira and things like that. And then AWS has CodeStar. For the deployment, Azure has automation, Google has Cloud Deployment Manager, and AWS uses Cloud Deploy. For the infrastructure automation, we have Automation Resource Manager templates that are given to us in Azure. You have Cloud Deployment Manager in Google, and in AWS we have Code Formation. So these are the basic services that are available within the major cloud providers. Lesson number 3, we're going to learn to implement DevOps in an on-premise environment. Project management tool, I'm familiar with Jira personally. I've used it before. It's pretty robust, pretty good. But you can basically use Jira for planning, assigning, tracking, reporting, and managing the work that individuals are assigned. And it actually does the assignment here as well. This tool brings all the teams in an organization together and helps them to work collaboratively for this software development and customer support. So they do have a workflow on the left that you can see from create an issue to where things get resolved. And the general statuses are open, in progress, closed, and reopened if an issue is found to have not been resolved to the satisfaction of customers or to someone else within the cycle. And on the right, you can see summaries of who's doing what at any given time. There's the dashboard view. It gives you a graphical interface to be able to see what people are doing within or what's occurring within this Jira space, what's been assigned and who's working on what. Confluence is a content sharing tool that helps every team in the organization collaborate in a single interface for creating and reviewing pages and project plans. Basically, use pages and spaces for creating meeting notes, project plans, requirement documents, and release notes, as well as for sharing content and business knowledge with the teams. You can see down on the left, you have the project management dashboard. As far as what project is going to be launched when, what phase they're in, and the overall status of it in relation to the schedule that they're going to meet. And on the right, we have the user story or dashboard. And basically, we're looking at the Jira type of language with epics and stories, etc. And it comes up and it'll give you all the notes, the importance, the collaborative kind of items you need within a particular story or a piece of this. Another project management tool is Slack. Slack's a messaging application for businesses that integrates with existing DevOps tool chains. It transforms an organization's communication by connecting every team with the required information that they need. It helps in finding and mitigating build errors at a fast pace to improve the productivity of software deployment. And here you can see the Slack dashboard and basically what it looks like as far as being able to interconnect everyone with the information that they need. There's meeting notes, etc., or just any kind of information that you need to share across. So let's look at an integrated development environment or an IDE. And this particular one is Eclipse, and we'll just give you kind of a view of what it looks like on the dashboard. But basically, Eclipse Integrated Development Environment is used pretty much for Java development, Java applications, etc. The base workspace and plugin system allows the developer to customize the Eclipse environment as far as how everything ties together and works, etc. So it gives you a basic place for Java code development, as you can see in the graphic. Another IDE for coding, Visual Studio. We're all pretty much familiar with Microsoft Visual, I'm sure. But anyways, it's an IDE for Microsoft that's used for code development. And it helps developers develop a project from the initial design to the final deployment. It's a good workflow type management, if you will, environment, as well as a pretty solid coding platform in and of itself. A source code management tool, GitHub. And basically, GitHub is the largest, most advanced software development platform that helps developers in building, shipping, and maintaining software. Go out and take a look at GitHub if you're not familiar with it. It's widely used across a lot of different industries for coding. And you can get a basic view of it here as far as what it looks like. GitLab is a DevOps platform that empowers organizations to maximize the overall return on software development by delivering software faster, more efficiently, while strengthening security and compliance in the builds. With GitLab, every team in the organization can collaborate in the plan, build, secure, and deploy pieces of the software development to drive business outcomes faster with complete transparency, consistency, and traceability. So it's a much more open way to allow your developers to interact on development projects and things like that. Maven's a build automation tool that focuses primarily on Java projects. It allows a developer to comprehend the complete state of a development effort in the shortest period and addresses several areas of concern that we have typically with development efforts, such as making the build process relatively easy and providing a relatively uniform build system. It provides a quality project information kind of a repository. And overall, it encourages better development practices. A continuous testing tool. Let's look at this. It's an automated testing tool to verify a web application across various platforms and browsers. So you can have a fairly wide array of what you're deploying to and what you're supporting from the user perspective with it. Selenium helps the DevOps team in achieving continuous testing by integrating with Maven, Jenkins, and Docker, some of your development environments. So the basic components of Selenium is you have the IDE, which is your development environment. You have a WebDriver and a grid that it operates within. Jenkins, widely used a tool when it comes down to an integration capability. Jenkins is an open source continuous integration and build server used for implementing this continuous improvement and continuous development pipeline. It can be used to automate software development phases, such as building, testing, deployment, etc. And it reduces manual work by doing this. And so you can see a basic workflow that you built on the left. And again, Jenkins is great for reducing your need to do a lot of manual pieces within that build, test, and deploy. Think of it as a workflow type of an engine. On the right, you see the delivery team, version control, build and test, the automated acceptance test, user acceptance test, and to the release of how Jenkins workflow actually bounces back and forth for feedback, triggering events, etc., with code check-in and approvals all the way out to the release. And of course, once we get that approval, you get the delivery, the notifications back. Any of these phases occur pretty much. You have these notifications and things that can be sent within the Jenkins tool as well. So it's great for a collaboration as well as automating the cycle. There's another continuous integration tool called Bamboo, and it's a continuous integration server that allows the DevOps engineers to automatically build, integrate, test the source code, and make sure the application's ready for deployment. And so basically what you do is you stage your workflows with the jobs, with tasks and jobs, etc. And again, it automates a lot of this so that you can spend your time coding instead of pushing code through processes, the different ones, as far as doing the builds and integrations of them. On the right, you can see the integrating the source code in the administration panel, and then the dashboard as far as what it reports back to you on progress, status, etc., for the different pieces of it. Infrastructure is a code tool. Terraform. Terraform is an open source infrastructure as code tool that can be used by developers for defining the required on-prem or cloud infrastructure for applications. Think of it as giving the ability to integrate your development with the environment that you're building to, or creating that environment that it's going to reside in. And so you have the installer dashboard as far as what's being put in. On the right, you see the basic workflow. So you have the practitioner and the community. With the public module registry, they can get in. You have infrastructure as code as far as plan, apply, and provisioning of it out into a production environment or whatever. So anyways, just think of it as being able to create that endpoint infrastructure integrated with whatever it is, the software is that you're developing. We'll get more into IAC tools in depth and talk about them in a bit. Another type of tool is configuration management. An example is Ansible. Ansible is an open source automation platform for automating various IT needs, such as configuration management, provisioning, and orchestration. It uses pretty simple programming languages such as YAML and does not require any agents or additional security infrastructure to be able to run it. And again, the orchestration is used to cluster things like containers according to their microservices, etc. Provisioning, shifting things up into your different environments. Template management, if you will. And here's the dashboard for it. You can see job statuses and what's happening with each one as they go through their runs. Another configuration management tool is Chef. A lot of people are familiar with this one. Basically, it's used for cloud infrastructure coding. It reduces the hassle of performing repetitive tasks manually for managing the infrastructure. You don't want to sit and configure every container, every server, everything that you have up in the cloud. And Chef basically allows you to automate according to standard series of templates or whatever you may be using. Using Chef for automatic configuration management allows DevOps engineers to write policies that are repetitive and reusable, and hence improves the business security of the systems by automatically monitoring and modifying them when required. So basically with Chef, you create a policy and a test policy, and you push it out to the cloud servers, on-prem servers, and edge devices. And once that policy is pushed out, you get a report back of what it looks like. Puppet is an open source automation tool for performing the configuration management of systems by defining the desired state of a system by writing code, basically. Automation expedites the software delivery process without compromising security. Basically, using Puppet in the DevOps culture helps to make infrastructure changes quickly and gives you the ability to release software with new updates frequently with the best quality. Puppet works architecturally by having a server, and basically you have your facts, a catalog, and a report that's generated off of the results of the agents being run, etc. And it also graphically provides you a report of the results out to you after you run it. Container management. When we talk containers, they're basically pared down environments for things to run in, applications or things like that. And one of the great container management tools is Docker. It's an open platform for developing, shipping, and running applications. Docker enables DevOps teams to separate applications from infrastructure so they can deliver software quickly. With Docker, teams can manage infrastructure in the same manner as the management for applications. In other words, you're defining your resources, think of calls and things like that within it. By taking advantage of Docker's methodologies for shipping, testing, and deploying code quickly, teams can significantly reduce the delay between writing code and running it in production. And on the right, you have three primary pieces to this, if you will. You have the client, the Docker host, and the registry. And you see how they're all tied together. Another tool for container management is Kubernetes. It's an open source platform that can be used for automating various manual processes such as deployment, management, and scaling of containerized applications. You have a control panel. You have the cloud provider API and the nodes. And so basically within all of this, you have an API server down here in tan. You can see those cloud controllers that are optional. You have a controller manager, etcd persistence store, what's called a kubelet, and a kube proxy, a scheduler, and a control plane node. So this is kind of how it all wires together. And as you play with it, you get to be familiar with each one of these pieces. And we'll talk more about them later on. Another continuous monitoring tool that you can deploy is Splunk. And basically Splunk is pretty fluid as far as how it gets deployed. Typically takes a fairly good expert to run, but you can get just about anything out of it depending on what you put into it. It's a software tool that uses machine data and big data for monitoring, analyzing, and visualizing machines in real time. IT teams at DevOps can greatly benefit from Splunk as it provides insights through all the stages of the delivery cycle. The main features of Splunk include the following, or the main pieces of it: data ingesting, data indexing, data searching, and alerts. These alerts can be customized out as far as what gets alerted and in what priority. It provides you great visualizations as far as what was discovered graphically. And again, it's fairly robust in what it can be applied to. Another monitoring tool is Nagios. It's an open source monitoring tool that monitors servers, networks, applications, and services in the DevOps culture. When an event occurs, Nagios alerts the security teams who investigate the incident immediately before it affects business. And actually, you can have third parties do this for you as well with it. But anyways, basically, you can see that the Nagios dashboard gives you current statuses, individual events that are color-coded according to the severity of what was found in the logs, et cetera, that it was looking at. Another one is Elk. Elk helps DevOps engineers make business decisions since they can have a centralized view of the logs to identify the problems with servers or applications and resolve them relatively quickly. And you can see by the dashboard down below, it's giving the status of everything and where issues might lie. So here's a basic summary of the DevOps tools that are available to us. And we're going to go into a little bit more detail with them later on as far as how to integrate them together and make them work in a cohesive, orchestrated fashion. But across the categories, you see continuous integration tools such as Jenkins, and it's open source. You have free, Bamboo, TeamCity, GitHub, Actions, Circle, GitLab, etc. You don't have any paid in there, but enterprise versions do exist for Bamboo, TeamCity, GitHub, Actions, Circle, and GitLab. Continuous delivery tools include, on the open source side, Jenkins, Argo CD, Flux CD, and Go. On the enterprise side, you have GitLab, Harness, and CodeFresh. Now, infrastructure and configuration management tools gets to be a little bit more broader as far as what specifically they can focus on. You have ones that focus specifically on infrastructure, such as Terraform, VM container images management and configuration, Docker, we spoke about that with containers, Packer and Helm. You have configuration management, Ansible, Chief, Puppet, and SaltStack. You have configuration service discovery tools, such as Console and etcd. Next, we have container clustering and orchestration tools. How do we bring these together for the microservices or for logical clustering of what they do in terms of their performance factors? Here we have container orchestration, can be done with Kubernetes, Docker, Swarm, and Mesos. Container security, we look at Docker Bench, Claire, Anchor, Engine. For compliance tools, we have Open Policy Agent and Docker Content Trust. For service mesh tools, we have Istio and Linkerd. Then we come to application infrastructure logging, monitoring, and visualization. In other words, when they're already up and running in whatever environment they may be in, or even if you want to test. We have three different pieces to this: logging, monitoring, visualization. For logging, we use ElkStack, FluentD, and Graylog. Monitoring, Prometheus, Sensu, Ryman, and Zabbix. For visualization, we use Grafana and Kibana. Then we have DevOps tools for collaboration, such as FlowDoc, Slack, Cisco WebEx, Teams, Flock, Google, and Hangouts. There are others as well. For planning project management tools, Jira is one of the big ones. Asana is another. Trello, Slack, Confluence. For source code management, GitHub, again. Bitbucket, GitLab, AWS Code Commit, Azure Repos, and Google Cloud for your cloud repositories. Developer productivity tools for the determining the efficiency of what you're doing. Environment setup, you have Vagrant, Docker, and Minikube and Minishift. For the API tools, SoapUI and Postman. For the IDEs, we have Eclipse, Visual Studio, Sublime Editor, Notepad. For DevOps build tools, we have Maven, Rake, MS Build, Gradle, etc. Artifact management tools for DevOps, primary ones are Nexus, NPM, and Nugget. JFrog is another one. For bug issue and tracking, we use Bugzilla, Mantis BT, Backlog, Jira. For test automation performance and testing tools, we look at things like Selenium, Appium, JMeter, and BlazeMeter for the open source. For the kind of like the free premium, UFT1 and JUnit 5 and BlazeMeter. So basically, in the last few slides, we kind of looked over some of the tools that are available to you for the different pieces of the DevOps suite, if you will. And I know we didn't go into a lot of detail about them or how they'd integrate, and we will get to that. But it was just to provide a basic look. Now, if we were to look at DevOps tools in general, there are these categories that we could lump them into logically. For instance, under the continuous integration tools up at the top left here, open source, we have Jenkins, Travis. Free is Bamboo, TeamCity, GitHub, Circle, GitLab. If you're looking for enterprise versions of these, you can again go to Bamboo, TeamCity, GitHub Actions, Circle, and GitLab. Under the continuous delivery tools, things that we keep this code rolling constantly into our different environments and different phases, we can look to Jenkins, Argo CD, Flux CD, and Go CD. Or free is CodeFresh. If we look at enterprise, there's GitLabs and others there. Now, when it comes down to infrastructure and configuration management tools, there are different silos of the types. You have infrastructure itself, which can be provided by Terraform on both an open source and an enterprise level. You have VM container image management and configuration that can be done by Packer, Docker, and Helm. Configuration management of specific pieces within your infrastructure can be done by Ansible, Chef, Puppet, and SaltStack. If you're looking for configuration service discovery tools, there's Consul and etcd. Then we get into the orchestration and clustering of resources out in the environment. And for a container orchestra, and again, think of the microservices or something that you want to collapse or pieces of your infrastructure into to provide services or a specific piece of the business. You have container orchestration that can be provided by Kubernetes, Docker Swarm, and Mesos. Container security, you can look to Docker Bench, Claire, Anchor, Engine for applying security to the container packages that you're shoving. For compliance tools, there's Open Policy Agent, Docker Content Trust. And then for service mesh tools, as far as maintaining everything across the mesh, there's Istio and Linkerd. For application infrastructure logging, monitoring, and visualization, those tools include three main pieces: logging, monitoring, and visualization of what's going on out there, of what you really have. For the logging piece, there's ElkStack, FluentD, and Graylog. For monitoring, Prometheus, Sensu, Ryman, and Zibax. Nagios is a free one out there. And then visualization, you can use Grafana or Kibana. DevOps tools for collaboration, as far as being able to collaborate across individuals, different teams, etc. Paid one is FlowDoc for kind of like your premium, freemium type of applications available within your enterprise. You have Slack, Cisco WebEx, Teams, Flock, and Google Hangouts. And not really enterprise level, I'm saying across your organization. More DevOps tools. include things like planning and project management. Jira is a rather large one out there, as is Monday, Asana, Backlog, Confluence, and Slack. For source code management, think library controls and things like that. You have GitHub, Bitbucket, GitLab, AWS, Code Commit, Azure Repos, Cloud, Google Cloud source repositories. For developer productivity tools, there's three basic types. You have environment setup, API, and IDEs. For the environment setup, you have Docker, Vagrant, Minikube, and Minishift. The API tools that are available to you for developer efficiencies. SOAP UI, Postman. For the IDEs, Eclipse, Visual Studio, Sublime Editor, Notepad++. The DevOps build tools, primarily, we took a real quick look at Maven, but there's also Rake, which is Ruby-based as far as the code on it. MS Build and PyBuilder for Python. You have Gradle, which is a multi-language support product. It's on a freemium column over there. Then you have your artifact management tools for DevOps. It includes Nexus, NPM, Nugget. JFrog is in there as well. I've seen JFrog used a couple of times. Pretty good. Bug issue tracking tools for DevOps. Probably one of the primary open source is Bugzilla. The free one, Mantis BT. And then if you want to get into the kind of free premium kind of thing, you have Backlog and Jira. For test and automation performance testing tools, Selenium, Appium, JMeter, and BlazeMeter come in mind with open source. As far as kind of the paid up levels, UFT1 and JUnit 5. And then for the enterprise versions, you have BlazeMeter. So again, these are some of the DevOps tools by category that you can look at putting into the environment to create your DevOps capability from end to end. All right, now we're on our lesson objective number 4, which is learn how to implement DevOps in an AWS cloud native environment. So basically, the DevOps has got a continuous deployment type of a model that's used up in AWS DevOps. And it's the implementation of the DevOps philosophy by Amazon. And it utilizes its cloud platform, dedicated services, and tools that are inherent within AWS to provide this environment, this DevOps environment, if you will. It automates manual tasks, helps teams manage complex environments, and reduces cloud complexity and maintenance with increased security and scalability. So if we look at this whole continuous deployment, kind of a range of what we go through, we have continuous integration and continuous delivery. The integration is planning, coding, building, and you'll notice that they kind of go back into each other. If you didn't get quite what you wanted, you continue to build and code, and then you hit the test point. So on this continuous integration piece, for planning, coding, building, and getting it to the test point, you can use things like AWS Code Commit, Jenkins, Terraform, Travis, Git, Chef, and AWS Code Pipeline. Then you get into the continuous delivery side where you're actually releasing the code, deploying it, and then operating it up in whatever environment you may be in, whether it's a customer test or a production environment. And over here for the continuous delivery, we use things like the AWS tools, Elastic Beanstalk, Code Deploy, X-Ray, Lambda, CloudTrail, CloudFormation, OpsWorks, ECS, Config, and CloudWatch. And we will get into those in detail later on and talk through those. So the AWS Code Commit is a fully managed, secure, and highly scalable source control service provided by AWS to host private Git repositories. So the Code Commit provides the following benefits to the DevOps teams. It gives collaboration. The AWS Code Commit is designed to use in collaborative software development. The DevOps team can easily commit, branch, and merge code. There's encryption that's provided. They can transfer files to and from AWS Code Commit by using HTTPS or SSH for your secure protocols. And the organization's repository is automatically encrypted at rest using the AWS KMS key management system using the customer-specific keys. There's access controls within the code commit. It uses identity and access management to control and monitor access to data. There's high availability and durability. Basically, ACC stores the repository in Amazon S3 buckets and Amazon Dynamo DB. And the encrypted data are redundantly stored in various facilities, making the data highly available and durable. So you're not looking at a just single repository either. Good for your DRBCP type planning. There's notification and custom scripts. A notification is generated if an event impacts the repository. Basically what you have over on the right, you see the workflow of code commit, the local computer. You have the AWS pushes the AWS create repository over to the commit. Get client and get init are your redundant cycles where you're going through and improving constantly. And then you have it pushed to a new repository. So you have the create repository, you do your work cycles, and then you go ahead and you push the project to that new repository. AWS Code Build, another piece of the suite that AWS provides, compiles the source code, runs tests, and delivers software packages that can be easily deployed in this environment. It provides the following benefits. You have a fully managed build service. The DevOps team does not need to install or manage software. It's extensible. The team can create customizable build environments. There's continuous scaling. By automatically scaling up and down, AWS Code Build can meet the target build volume of an organization's DevOps teams. It enables continuous integration and delivery. The DevOps team can use AWS Code Build for automated software release workflows, and it can be easily integrated into existing continuous improvement and continuous development pipelines. One big thing is it's a pay-as-you-go. It's based on your usage of this service. So it's not a single fee and you hope that you use it at some point. And it's very, very secure. The built artifacts are encrypted with customer-specific keys. You define them, which are managed by the AWS Key Management System. In addition, Code Build is integrated with the AWS IAM side of the house, which helps the DevOps team control access as far as who can do what. It's the roles, permissions types of base. So if we look over to the right, you see the workflow of the AWS Code Build. You start over with the Amazon Web Services code pipeline, and the Web Services Code Build environment bounces back and forth. You'll have source code and build projects integrated into it and get shoved up into the buckets. You have the results of that are shoved out in the CloudWatch logs, where you can actually see what's going on in the Web Services Management Console. So it's a fairly holistic system. AWS Code Pipeline. It's a continuous delivery service provided by AWS, and it helps the DevOps team to automate the release of pipelines for quick and reliable application and infrastructure updates. At each instance of change in code, the AWS Code Pipeline automates the build, test, and deploy phases of the release process, again, freeing up your resources and allowing automation to take over and move the code through the different phases. So it provides the following benefits. There's rapid delivery. Automation of the software release process allows the organization to release software more quickly and surely with less error as far as the actual deployment goes. There's improved quality. Running all new changes through a consistent set of quality checks improves the speed and quality of the software that's being delivered. And it's relatively easy to integrate. This can be easily extended to meet the DevOps team's requirements as far as the scaling of what's being done. And there's a configurable workflow so that you can interactively change pieces of the workflow to suit your specific needs within the program that you're running. So it's a continuous kind of a cycle. You have ideas, requests, and bugs that come into the developers, and they look at the source. They do the source code. Developers commit the changes in source, and they build it out. Then you have staging where the code is deployed and tested. It can be tested, stress tested, functional tested, security tested, whatever you want to test it for. Then you have a manual approval that's logged and flagged in there before it goes to production. And at that point, the code's deployed to the public servers so that customers can now interface with it and use it. And of course, they're going to say, that's not what I wanted. Let's do this again. And you see this continuation that goes back. They get ideas, requests, bugs, etc. This is how most shops run anyway, so it fits very, very well with the DevOps model. AWS Code Deploy is a service that automates the deployment of software to various compute services, such as the Amazon EC2, Lambda, and the organization's on-premises server. It provides the following benefits. Basically, it automates the deployment. Again, minimizing the human error factor kind of side. It automates the deployment of software to the development, test, or production environment. It supports servers as well as serverless and container applications, which is good. It gives you some flexibility in what infrastructure you're pushing to. It's relatively easy to adopt. The DevOps team can easily integrate AWS Code Deploy with their exhausting software release processes. So it's another process integration that you do with this. It minimizes downtime. At the time of the software development process, AWS Code Deploy maximizes the availability of the application and minimizes downtime. It also provides central control. An organization can launch and track the status of a deployed application via AWS CLI or AWS Management Console. So you have a full view of what's going on, and it provides reports as far as where you're at in the process. So basically, you have the dev team that does a push to GitHub. It triggers a code deployment, and then you have the code deployment that occurs in the Elastic environment over there on the right. The next piece that AWS provides is CodeStar. The CodeStar service helps the DevOps team in rapidly developing, building, and deploying applications on AWS. It can set the continuous delivery toolchain in a few minutes using AWS CodeStar and release the code quickly. It provides the following benefits. You can start developing a project quickly. Using AWS CodeStar, the DevOps team can quickly and easily start the development and continuous delivery of application code. You can manage delivery of the software in one piece. The unified user interface provided by AWS CodeStar helps the DevOps team collaborate on and monitor day-to-day development activities. You can secure the entire work environment. The built-in role-based policy provided by CodeStar allows the DevOps team to collaborate and work securely. So everybody's assigned a role and what permissions you have. There's provisioning of project templates. The DevOps team can also develop various applications such as websites, web services, and web applications using AWS CodeStar project templates. So on the right, you can see the workflow of AWS CodeStar. Basically, you have an admin that creates projects and adds users, gives them the rights, their permissions, etc. The developers commit changes, the changes are integrated into a build and are deployed. At that point, monitoring of the application infrastructure kicks in, and the customers can see what's going on. So through the monitoring or through the ideas and requests and bugs that the customers find, you get feedback to the developers as far as making decisions on what you're going to do next. And at that point, you plan changes, updates, and fixes, and the cycle starts over again. So let's say you have a platform as a service application and you want to deploy it. Within AWS, you'd use Code Pipeline to do this. You'd implement following steps in AWS to deploy a PaaS application using Code Pipeline. The first step is to create an application in the Elastic Bean stack. Using the AWS Elastic Bean stack, The DevOps team can create simple applications very quickly. To create a platform as a service application in Elastic Beanstalk, you'd select the app name, platform, and application code and click on Create, as you can see in the graphic there. And here we created deployment app dash environment. So step 2 in creating a pipeline. You'd go to the AWS console and enter code pipeline in the search box. You click on the Create Pipeline button, set the name and the role name, and click Next. Add GitHub as the source provider and connect to GitHub. Next, you would select the repository in the branch and click Next. You add the build stage into it, then you add the deploy stage and select the provider app name and the environment when you do this. Click Next. You review the details, after which the pipeline has basically been created. Now in the deployment stage, the pipeline's working if an instance is running, the source status is succeeded, and the deployment status is marked as succeeded, as you can see here. Right about the middle of that graphic, 8 minutes ago, you got a succeeded message, and the pipeline was successfully created. So now we're on lesson objective 5, learn to implement DevOps in an Azure cloud native environment. Very similar to AWS, but of course it has its differences, slight ones. And we'll walk through those real quick. Azure DevOps offers developer services in the cloud to help development and operations teams with planning work, code development, building, and deploying software products. With Azure DevOps, the organization enhances productivity and develops software products at a faster pace as compared to the conventional software development approach. Basically, it's kind of broken into cloud and either on-prem or hybrid pieces to it. On the cloud side, you have websites, cloud services, SQL databases, etc. Visual Studio Online for building continuous integration and deployments, etc. Now, with the other piece of the infrastructure, you can have hybrid or on-prem Microsoft products integrated in as well. System Center, Microsoft Hyper-V servers, lab management team foundations, or Visual Studio. On the people side, this integrates business, IT operations, and the developer testers kind of into one environment, which is good. It gives everybody a voice in what's going on. The process is relatively simple. Plan, monitor, learn, release, develop, and test. And all of this is done in a collaborative method with business, IT operations, developers, and testers. And on the right, you see basically what the dashboard looks like. Graphical, colorful, pretty, and relatively straightforward, easy to use as far as going and creating what you need to do or looking at reports at how things are going. So the Azure DevOps tools and services that you have access to, there's a lot of different integrated features that can be easily accessed by the DevOps team through an IDE client or a web browser. Either one will work. Depending on the business requirements, the organization can utilize one or more of the following standalone services provided by Azure. The DevOps tools and services for development. On the plan side, you have Azure Boards and Azure Repos. For code, Visual Studio Code. On the build test side, Azure Pipelines, Azure Test Plans. On the release for ops, you have Azure Pipelines. Deploy, Azure Lab Services, Kubernetes, Container, and Azure Virtual Machine. For operate or running the environment, you have Azure Blueprints, Security Center, and Dev Test Labs. For monitoring how well everything's performing and doing up in the environment, you have Azure Monitor, Application Insight, Azure Test Plan, and Network Watcher. So over on the side, you can see that there's tools and services according to boards, pipelines, repos, marketplace, artifacts, and test plans. Azure Boards help DevOps teams in planning, designing, and tracking the workflow with Agile, Scrum, and CMMI processes applied to them. Agile is the quick kind of a development methodology. Scrum is a development methodology based on kind of iterative and incremental processes. And then CMMI is your maturity scale, if you will. It's the CMMI model of 1 or 0 being completely immature, 5 being very mature. So you can see an Azure board's dashboard and what it looks like. Tracking work on backlogs and boards. Azure Boards is used to update the work status and add new tasks under the new item and determine active, resolved, and closed sections. And it uses a Kanban board. So basically you can see tracking work with boards as far as the who's got it and what they're doing. You can add items and tasks and things like that to be able to do. Now, Kanban is a kind of a framework used to implement Agile and DevOps software deployment. It's real-time communications typically, and provides a little bit more transparency into your work. Azure Repos is a collection of version control tools used to manage code. It helps track changes in code over time. So think of this as your change control repository of who did what, when, what was done. Azure Repos offers Git and Team Foundation version control for everything. So it's actually library versioning control kind of integrated in to the Azure side. One thing that Azure Repos is really good with is you can review and merge code changes with a pull request in Azure Repos. Basically what happens here is a dev team can fetch code from a repository to review it for bugs and merge it in a single collaborative process. After fixing the bugs, the dev team needs to create a new pull request. So basically it manages that problem resolution and getting that resolved code back out. Azure Pipelines automatically builds and tests code in any programming language or project type. For testing and building the code, it combines continuous integration and continuous delivery and ships the code to the target. So think of it as the one that kind of sweeps the code along for you in an automated fashion so you don't have to manually do this. It's set in as part of the workflow, if you will, and reduces errors and things caused by manually doing the job. Deploying an ARM or an ARM project with Azure DevOps pipeline. Now, ARM templates give you a way to save the configuration in code, basically, is what the ARM is. Using an ARM template is an example of infrastructure as code and goes back to a basic good practice here. So anyways, DevOps team can use Azure pipelines for deploying this type of code to various targets, such as virtual machines, Azure services, container registries, or other on-premises targets. To deploy the project with Azure DevOps pipelines, you select the project in the repository, then select the template from the repository along with the parameters file and deploy the project. You pull it out of your repository and deploy. And basically you can see this in the user interface and the actions that are being taken, what's going to happen here. You see the Azure Resource Group deployment and the deployment, the Azure Resource Manager template gets put to a resource group. Azure Artifacts. We mentioned artifacts before, all of the associated bits and pieces that go along with this. Developers can share and consume packages from various feeds and public registries using Azure Artifacts. It allows package sharing within the same team or organization, or you can do it publicly, in fact. So as you can see in the graphic, you can take a wide range of artifacts, whether they're .libs, frameworks, apps, whatever it may be, and you can share it across wide teams or just individually within a single project team if you wanted to. Makes it very, very simple to do so. it's a good way of organizing these, I guess, for usage. You can use Azure artifacts to publish and consume NuGet packages. A NuGet package is a simple zip file with an extension that contains compiled code. The extensions typically .nupkg. But anyway, so the DevOps team can use Azure artifacts for publishing and consuming NuGet packages from public registries and feeds. The team can create private and public feeds that can stringently control access to the feed through the feed's permissions. And basically, it's provisioning access through it. But you can see what configuring a NuGet artifact with Visual Studio looks like, for instance, down below. Azure Test Plans. This module conducts planned and exploratory testing services to improve code quality for applications. Using Azure Test Plans, the DevOps team can test the application across the web and desktop, capture rich data, and achieve end-to-end traceability. So basically, this is the way that you would go ahead and start introducing some tests into your platform here. As you can see, it's very, very graphical on the output. It tells you what failed, what passed, and zeroes in on issues rather quickly. Running automated tests using Azure Test Plans. The DevOps team can run automated tests from ATP, which is user-friendly. It's for testers who are not well acquainted with running tests in build or release workflows. So it makes it a little bit simpler for them, I guess. The Azure Test Plans allow the DevOps team to rerun tests that failed because of infrastructure failure and provides the flexibility to run the selected tests on demand. So you can create the tests, run the tests. If they fail for whatever reason, you do the repairs, you come back, you run the same test, and you'll get the graphic output that you see on the right as far as the results of your testing. And again, it's really good for people, for the testers who aren't well acquainted with running it in the build and release workflow side of the house. Azure Application Insight is an Azure monitoring feature that helps the DevOps team in monitoring a live application. So here we are with the monitor side of it to see how it behaves. Using Azure Application Insight, the DevOps team can automatically detect performance anomalies, diagnose issues, and understand user activity associated with that application and see what's going on kind of with it in a run state. And as you can see in the graphic, you have fairly strong output as far as what's happening with the application, and you'll understand how it's behaving in the environment. So you can also do a little bit more monitoring with Application Insight and look at the performance of your application, how well it's doing in the environment. So you use Application Insight to generate and review application traffic, investigate the performance of the application, track the usage of it, and create application alerts. So down below in the graphic, you can see that it shows failed requests, for instance, or the number of server requests that were hitting it within a time span when it happened. You'll be able to see peaks and valleys of its usage or whatever. You can also see server response time, how fast the information is flowing between the application and the infrastructure. And last of all, you can see the availability or the uptime of the application or within the system. So let's move on to the next objective, which is understand the frameworks and maturity model in DevOps. So what we're looking at with the DevOps framework is culture, automation, measurement, and sharing, or CAMS. This is a framework used to determine an organization's ability to adopt DevOps culture. In other words, how prepared are you? Think of it almost like a CMMI type measurement, as well as are you ready to step into DevOps? Because if you're a waterfall only shop and you're thinking about going into this, there's quite a bit to do as far as connecting up the automation to different groups. How far into it do you want to go? Do you want to go all the way out to infrastructure as code, Are you going to step back into just cycling through a couple of environments on-prem with the customers and production side of it interfacing? So CAMS gives you an ability to sit back and kind of take a look at, are we ready for DevOps? So CAMS breaks down into culture, automation, measurement, and sharing. Basically, culture is defined as the interaction between different people and groups in an organization. The automation of processes helps to reduce human errors and avoids time-consuming iterative work. We talked about setting up containers and servers and environments and things like that, cloud instances. Are you able to take on the automation process of it? Because it does take engineers to do this, obviously. Then there's the measurement. And basically what we're looking for is the progress of various DevOps activities that should be measured using different metrics and KPIs for continuous improvement. And then last of all, are you able to share in your organization new discoveries, best practices, and feedback? We should look at an environment that's ready to adopt a very transparent type of a stance when it comes down to doing development. It also helps different teams work together to achieve a common goal. And typically sharing is something that's on the social side can be siloed in a lot of development efforts in organizations. So it's something to consider. What is the DevOps maturity model really? The DevOps maturity model is a conceptual model that determines an organization's place in the DevOps journey and helps in identifying what more an organization must do to achieve its targets. It serves as a tool to evaluate the efficiency of the organization's processes, or even the maturity of them. To achieve DevOps maturity, DevOps must be embraced as a continuous process rather than just an individual goal. And so typically think of it like if you start down the DevOps path, it's not, ready, set, go, and you're kind of like done. It's an iterative process of integrating tools and technologies and refining processes, etc. The DevOps maturity approach helps in determining growth through continuous learning from both the development and the operations teams and from the perspective of the organization. So how do we go about measuring DevOps maturity? Again, we have the four categories: culture and strategy. DevOps should be viewed as a culture-driven method that incorporates multiple work groups to achieve a shared goal. Within business operations, you may have silos of functionality that provide large pieces of features and capabilities out to customers, and that could be siloed and towered, not interacting well across the broader culture. So you have to look at, are we able to adapt to achieving a shared goal? The automation side. The purpose of automation is to improve code quality by preventing issues before they arise with continuous testing. Are we ready to take that on? All right, within structure and process, DevOps gives a really high importance to structure and process. Everything is laid out in workflows and gates and checks and things like that as this whole rolling tide of developments occurring. So IT functionality, and both dev and IT ops, becomes much more process-oriented with DevOps. There's a lot more collaboration and sharing in this model than others. It prioritizes collaboration and sharing. To attain common aims and objectives, the teams have to align their tools and synchronize not only what they see, what they're working on, what they're doing, but they have to synchronize these technologies so that they work together well and produce the desired results. Like I said, it's not just an easy pull the trigger and we're a DevOps shop. So those are kind of like the four main pieces that we look at when we measure organizations for the readiness to be able to adopt a DevOps model. And of course, like any kind of an improvement model or a stages model, the DevOps security model has its stages as well. Basically, there are 5. And it's what every organization has to follow while assessing the maturity levels of their DevOps program. Number 1 is an initial stage. And here we have development and operation environments are separated or established separately. It means they're not really connected through very well. When we get into a managed stage, or the stage 2 of maturity, this stage focuses on agility and development and automation and operations. So we're starting to see some automation and faster development capabilities. When we get into defined, we have more clearly defined processes, and automation is fully established, or at least heavily relied on for the operation of DevOps. The next maturity stage is where we see measurements starting to kick in. And we're talking about performance indicators of the dev team, or the results of customer satisfaction, whatever. We get to a point where we can actually start measuring what's being done in DevOps. It's an enhanced understanding of process and automations attained. And also you kind of see the idea of continuous improvement and continuous development prioritized, if you will. In the last stage, we see optimized. Here, you're at one with DevOps. This stage improves teamwork. It standardizes the processes. You have visible results and acknowledges the team's efforts. So one of the main things that you see in an optimized organization is you see acknowledges the team's efforts. You have a feedback loop and a kind of like an after actions type of perspective. How well did we do with this? Where can we improve? You see this drive towards optimizing what's done with the DevOps program. So basically there are 3 main components of the DevOps maturity model. Where does it get applied or measured at? And these are the components of it. We have applications, data, and infrastructure. So DevOps maturity for applications, we're looking at the security of the application development process from the development to the production stage. And it determines the DevOps maturity for applications and what's being done with them. Then we have DevOps maturity by data. Basically, we're looking at data operations and what they do to act on automatic data changes, and how it verifies the functionality is determined by the DevOps maturity by this data layer. And last, we have the DevOps maturity by infrastructure. And this is looking at the capability to simplify infrastructure handling skills, automating this stuff. Pertaining to automation determines DevOps maturity by infrastructure. How do we actually reduce the workload, the manual application of infrastructure with our DevOps capabilities? So what do we look at for maturing practices? What do they look like within each slice of this, if you would? So from a culture and processes, you're at level 1. If you have it kind of defined and documented, you have prioritized work, and it's, you're documenting your frequent commits, etc. But when we start to move through better processes, we have one master backlog, one backlog team, and testing and development boundaries are removed, and we use basic agile methods. On a level 3, we see team collaboration, common processes for changes, response to metrics, and we remove the boundary between between the development and the operations, the IT ops teams. When we reach level 4, we see a dedicated team for automation tools. This is engineers are applied to the organization to be able to configure, customize, and implement DevSecOps tools. You see continuous improvement. You have deployment is disconnected from release cycles. When you hit level 5, as far as the culture and processes, basically you're working with cross-functional teams and very few, if any, rollbacks, because it's matured to a point where you're deploying known sure code pretty much at every release, not having problems with it. For architecture, on level 1, you define the context view or the physical composition or logical composition of systems. Level 2, you get the defined related views, such as staging SDD wiki with views in place. A level 3 example is reviewing processes that are in place for that improvement of what you're doing. The last, for level 4, you have automation that kicks in basically, and you start seeing metrics for success or failed builds, let's say. A level 5 on this would be socialized results for continuous improvement, reviews, etc., and tuning everything according to the output. For build deploy, a level 1 would be a version code base or a dedicated build server, scripted builds, documented but manual deployments, and basic scheduled builds. If we move into a level 2, we're looking at polling builds, manual versioning, manual tagging, first steps towards standardized deployments where we're doing everything in a very standardized process. And the builds are stored somewhere. As we get into level 3, we see automatic tags or automated bulk of database changes, versioning, and triggered builds are being automated at this point. You have standardized processes for the environments, changes in scripted configurations and baseline pipelines, or basic pipelines with deployment to production. Level 4, zero downtime deployment. You're kind of getting out of the Hicks and Burp stages of getting this deployed, the DevOps deployed within the build deploy phases of your operation. You're seeing fully automated database deployments and multiple build machines are now available in the environment. And when you're fully mature, you'll see zero-touch continuous deployments. Basically, you're updating, you're doing code, pushing it out, build to deploy is happening fairly automatically on that backside of it. When we talk about test and verification, automated unit testing, you have coverage of more than 50%, but less than 80%, let's say. You have automated integration testing, but the coverage is somewhat unknown as far as how broadly it's applied across the entire DevOps program. In level 3, you start getting into automated functional tests and acceptance criteria of less than 40%. So when we get up into a level 4, you'll see automated acceptance criteria hitting up around 80%. Compliance tests with like 508 for your web content accessibility guidelines, let's say, or something, is now hitting full automation. You have automated performance tests and security testings happening. When you hit level 5 automation for tests and verifications, you're looking at pretty much 100% coverage of what you're producing, and all the tests are automated. When we look at collaboration and information sharing, level 1 is where we have manual reporting and some baseline process metrics. There's not a lot going on as far as that goes. But then we start seeing in level 2, we're picking up static code analysis and quality reports. At level 3 for the sharing, we see traceability into the pipeline and availability of history reports and what's been done. As we mature this up, we'll see reporting on trends and getting to do that analysis. And see graphing as a service. Finally, level 5, we see dynamic graphing and reports are accessible via a common dashboard. So it goes from folks not really seeing a whole lot to where everybody has visibility and very graphical output views of what's being done within the environment. So in order to for DevOps to succeed, there's a couple of principles or premises that you really need to adhere to. From a customer-centric approach, you need to be focused on the customer experience at every stage of the software delivery pipeline. You look at having things more production ready earlier on in the cycle. You're kind of delivering production ready code, although it's not deployed into the production environment immediately. And the teams are always ready to be able to either fix problems or to roll things forward, etc. It's like everybody is actively engaged and pretty busy. You have an uncompromised quality. You're ensuring that high quality software with very few failures is deployed to ensure this continuous delivery not only is profitable but effective. You hold teams accountable for the quality and quantity of a service that they're providing within this DevOps capability. And you recover from failures fairly rapidly. So Within the area of collaboration or cross-functional autonomous teams, you want to ensure the development and operation teams are working together very, very closely, and that the teams are fully autonomous throughout the product life cycle. You want to ensure that the teams have the expertise for creating uncompromised quality of the product. Make sure that they have their training and that you take care of them in that stop. Next, you want to ensure the teams have the expertise for creating uncompromised quality of code in their product, training, etc. for them. When it comes to repeatable delivery, you want successful delivery to be a constant throughout, or to be able to constantly do that. Frequent build and integration or development speed. We're looking for delivering features in small increments at a much higher pace rather than large chunks of things like were found in the agile approach, where you just started the whole cycle over. We're looking for more discrete packets of improvements. Application stack consistency. Here we're talking about provisioning and configuring the application stack for ensuring consistent user experience. We're also wanting to reduce external dependencies in the application stack where we can, create the efficiencies. With application monitoring management, we want to monitor applications continuously to detect defects before customers detect them and report them back to us. With test automation, we want rapid turnaround with minimum manual testing. There's a place for manual testing. We want to automate as much as possible. For declarative configuration management, we really want to focus on what the environment's supposed to be when writing configuration files and focus on what we're trying to create here. So what are the best practices for successful DevOps implementation? You want to evaluate accurately the goals of the DevOps implementation. What are you trying to achieve? Are you going for full automation? Something in between to where you have, according to your organization, you need to attain a certain level of it in order to be successful? How much are you willing to invest as far as skills and things? You want to break the organizational silos and encourage collaboration among teams. That's a real biggie. Typically, IT ops, and developers have been pretty separated. And with a DevOps type of an approach, they need to be brought together very, very closely. You want to ensure that the client or end user satisfaction is given the highest priority. Whoever's using what you're making is your ultimate bellwether test of how well you've done. You start with small goals and then scale up. Don't try to bite off more than you can chew with a DevOps program. As much as possible, automate testing and the build environment. When it comes down to creating the builds and pushing code out to production, the more that you can automate the builds, the testing, et cetera, that occurs in those last stages, the more successful you'll be. You want to select tools that are compatible with each other. There are certain ones that go together very well. Some of these tools that we'll look at are very, very easy to integrate a wide range of things into. Some of them aren't. It takes a lot of scripting, a lot of manual bashing to be able to get them to come together. So when you look at this, try to select things that are compatible with each other as far as the big pieces of your DevOps program. You want to make sure that you design and define performance reviews for the team and at an individual level as far as metrics, goals, how well they're performing. Ensure real-time visibility into the project. At any time, you should know where you're at with the build cycles, with releases, coding, et cetera, testing that's going on, and what that looks like on a calendar of events. You should integrate configuration and change management into this. One problem is with high compliance environments, like for SOX controls or HIPAA, et cetera. A lot of them require that you manage change and configurations very, very closely. You want to make sure that you have continuous integration and continuous deployment. There are no lags when you're doing DevOps. It's a rolling cycle that keeps moving forward, and you're marching to the dates of the releases and the reviews and the coding and everything else. It's a continuously moving kind of a machine. You want to have continuous delivery and product support throughout this. Make sure that that it's a constant level. Break down packages in more discrete, smaller releases if you need to, but keep it a continuous paced type of an operation. You want to ensure that the application monitoring and automation of dashboards is in place. And this gives you better feedback so that you can see actively what's going on in an automated fashion. You want to know how something's performing or whatever. You flip up a dashboard, tells you how well it's performing as far as connections or latency within the system or things like that. You also want to ensure that you have active collaboration with the stakeholders. Stakeholders can be business unit owners, can be the endpoint customers. If you're a large SaaS shop, typically you have direct feedback mechanisms and loops, help desks, etc., environments for them to play in and look at to see and understand the end user problems and fix them. So it's really important that you have that not only active, but I'd almost say an interactive collaboration that occurs. So let's evaluate the security silos that can be inserted into the DevOps operation. There are some bottlenecks to the DevOps process. Basically, DevOps is looking to automate the build and deploy phases of software development. However, unless all the teams responsible for the planning, building, the delivery of software are connected, the bottleneck kind of only moves forward. What's the security impact of this? On the left, you see some problems that organizations run into generally when we talk about these environments, development environments. But basically, security steps in as potentially another issue here. Security audits can become a bottleneck to the DevOps process because applications have evolved into microservices. These microservices need APIs for communication with each other, and it increases the attack surface. In other words, the things for a cyber criminal to find that may be vulnerable and exposed. Even the services that are used by microservices, such as databases, message brokers, etc., further broaden the attack surface. These services run in a container, which is another layer where security issues may arise. Containers, we'll talk more about creating templates and things like that and what the container looks like. But basically, it's another layer of attack. One of the things that's really interesting as a security professional is how our attack surface is so broadened by this. On top of that, cloud instances, they run on cloud platforms such as Kubernetes cluster. There are a lot of layers of infrastructure, applications, and components that need consistent security applied to them. The security team has to learn how to identify those issues. Many security tools that are used by security professionals were developed before the use of Kubernetes or some of these other Microsoft microservices, etc. Therefore, the security professional must find or create new tools that can work within modern application setup. Things have changed. The security professional has to migrate with them. Typically, before deploying the application to production, the security team checks the application for vulnerabilities and other security issues. Depending on the complexity of the application, it can take a lot of time to determine the security or the vulnerabilities, details about a vulnerability. And even after determining the vulnerability, the security team has to send the application to the developer for fixing the problems. However, in the efficient DevOps process, a new version will be created, which will be in queue for a security audit. Thus, the security checks and audits block the DevOps process and delays the release. And this is why we're here today, is to talk, or within this course, what do we do about this? These issues with security kind of creating one of the bottlenecks as things move forward. The whole idea of DevOps is to remove bottlenecks. We want to make sure that security doesn't become another bottleneck in the whole DevOps phase or the process. So here's our DevOps security challenges. We have security breaches while managing secrets with DevOps tools. These built-in capabilities of the DevOps tools for safeguarding secrets do not enable secure secret sharing over tools, systems, or clouds. And sometimes Secrets have been published up in public repositories, IDEs, et cetera, that exist up on the web. And collaboration issues, collaboration and security issues occur when roles and policies are not clearly defined. Kind of an IAM approach to how we're supposed to manage this whole process, from who can do what are the roles that we have. Vulnerabilities in software supply chain. A lot of times open source libraries, et cetera, can have vulnerabilities inherently baked into them. So these libraries and frameworks are a major security challenge to us. Containers and other assorted tools. In the absence of appropriate safeguards, these can pose security risk as containers share the OS and are less frequently inspected for issues. Switching to a serverless computing model has several flaws, such as the uncertainty in the platform security until the application is deployed and the risk of secret exposure during the transfer process, during the deploy process, if you will. There can be a lack of security ideology. And that's one of the more worrying things when it comes down to security professionals. We want everybody to have, or we want to build secure aware cultures, et cetera. Particularly needs to be done in DevOps. There are compliance requirements. These standards include proper function and performance testing before releasing to production, and the restriction that only authorized personnel can deploy software into production, let's say, or even basic compliance rules such as with HIPAA and PCA and SOX, et cetera. So you have internal compliance requirements, external, and violations can compromise the security of what's being built and deployed. There's a lack of integrated testing tools. Owing to the lack of integrated security testing tools, there's a risk that code containing a serious vulnerability could be deployed. This could pose a threat to the security of the overall project, certainly while it's up in a production environment. Scalability issues when it comes to threat modeling. Owing to the evolving threat landscape, the threat models built today probably aren't as effective tomorrow, making it difficult to determine the security risks with applications and environments. It's a constantly changing threat landscape that we face. And finally, a big challenge of ours is the lack of secure coding standards. There's a lack that can lead to leaked secrets, service interruption, vulnerabilities in code, poor coding, I'd want to say in design. And SCAs are one way that we can address that, certainly. But anyways, so these are the challenges that we have when it comes down to DevOps from a security professional perspective. Module summary. Let's go through what we kind of talked through today on this particular module. Organizations use different methodologies for software development, which continuously evolve and have advantages and disadvantages. We talked about the big three. The waterfall model does not work very well if flexibility is needed. Thus, the agile model was introduced. When the agile model failed in delivery efficiency, DevOps was introduced to enhance the efficiency of application delivery. The main goals of the DevOps methodology for developing software include a low error rate, achieving business needs and customer requirements, enhancing productivity, managing the interaction between different departments, and optimizing development task responsibilities. The phases of the DevOps pipeline in an on-premises environment are plan, code, build, test, release, deploy, operate, and monitor. The processes used to make changes in the developer's main code branch are continuous integration, continuous delivery, continuous deployment. The main difference between on-premises DevOps and cloud-native DevOps is in the delivery method. In the cloud, the release and deployment are pretty much the same. Culture, automation, measurement, and sharing, or CAMS, is a foundational model of DevOps used to determine the ability of an organization to adopt a DevOps culture. The DevOps maturity model is a conceptual model that helps in determining the position of an organization in their DevOps journey. That concludes Module 1. I hope that was interesting enough to keep you engaged in thinking about where we're going to go with security in the DevOps model. See you in the next module.